Texan Global School. Graph of the trigonometric functions. In this class, we will discuss processes for graphing trigonometric functions. Initially, we have the simple argument trigonometric functions, which are those represented as f of x equals sine, cosine, or tangent of x. Let's look at the detailed parts of each function. A is the amplitude of the function. B is a positive constant that will determine the magnitude of the phase dividing alpha by b. X is the independent variable. Alpha, the phase angle, which shifts the graph to the left or right. The period of the function is the minimum length of the interval in which the pattern of the function is repeated, and it is obtained as 2 pi over b. Any part of the graph that shows that pattern is called cycle. In order to sketch the trigonometric functions, we will use the unit circle and the exact values seen in previous classes. The summary is shown in the circle. Start the cycle at 0 degrees or 0 radians, then 30 degrees or pi6 of a radian, until completing the cycle of 2 pi. To tabulate, use these values and substitute them into the function. In this first example, let's sketch the sine of x. Likewise, we will find the domain and range of the function. Tabulate a cycle using the values obtained in the unit circle. Place, as an independent variable x, all the values in radians of the arcs, starting at 0 up to 2 pi radians. Substitute each value into the sine of x. In this way, obtain the coordinates x, f of x to graph. If we compare the points on the graph, we can see that they coincide with the exact values obtained in previous classes. If x equals 0, the sine of 0 is also 0. If x is half of pi radians, the sine of half of pi is 1. Graphically, it is the highest point of the graph. If x equals pi, the sine of pi is 0. If x is 3 half of pi, the sine of 3 half of pi is negative 1. And if x is 2 pi, the sine of 2 pi is 0. We can see that we sketched a cycle of the function. The length of this cycle is called the period. In this case, 2 pi. The numerical coefficient of the function determines the amplitude. In this case, the amplitude is 1. Now, let's sketch 2 cycles. We can graph a cycle backward or forward. Graphing a cycle backward, simply take the same values of x, but negative, and add the function. We can see that the period is the same 2 pi. For this reason, these types of functions are called periodic. The amplitude is the same, in this case equals 1. Let's look at another example. We will sketch the cosine of x, also find domain and range. Tabulate a cycle using the values obtained in the unit circle. Place, as an independent variable x, all the values in radians of the arcs, starting at 0 up to 2 pi radians. Substitute each value into the cosine of x. In this way, obtain the coordinates x, f of x to graph. If x is equal to 0, the cosine of 0 is 1. If x is half of pi radian, the cosine of half of pi is 0. If x equals pi, the cosine of pi is negative 1. If x is 3 half of pi, the cosine of 3 half of pi is 0. And if x is 2 pi, the cosine of 2 pi is 1. We can see that a cycle of the function is sketched. The length of this cycle is called the period. The amplitude is determined by the numerical coefficient of the function. In this case, the amplitude is 1. Now, let's sketch 2 cycles. Graphing a cycle backward, take the same values of x, but negative, and we add the function. We can see that the period is the same 2 pi. For this reason, these types of functions are periodic. The amplitude is the same, in this case equals 1. When analyzing the graph, we can see that the cosine has the same behavior as the sine function. The only difference is that the cosine is shifted or moved 90 degrees or half pi radian. Let's sketch the tangent of x in this last example. Tabulate a cycle using the values obtained in the unit circle. Place, as an independent variable x, all the values in radians of the arcs, starting at 0 up to 2 pi radians. Substitute each value in the tangent of x. In this way, we obtain the coordinates x, f of x to graph. If x equals 0, the tangent of 0 is 0. However, the tangent of half pi and 3 half pi does not exist. Graphically, they are represented as asymptotes, meaning that the graph presents discontinuities and the values that tend towards infinity. The more values proposed from 0 to pi means, the graph will tend to positive infinity. Values from pi to half of pi will tend to negative infinity. Graphing two cycles, add the other part of the function. The period is the same, 2 pi. Once again, the discontinuities are represented graphically as asymptotes in each of the function cycles. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com